Section 2.2 is called Limits Involving Infinity. A more accurate name for this would actually be asymptotes. We're going to be talking about two types of asymptotes. This video is going to focus on the vertical asymptotes. There really shouldn't be a whole lot of new information here. A lot of this you've learned how to do in algebra and in pre-calculus. So kind of a quick refresher from algebra, how we identify vertical asymptotes. Vertical asymptotes are values that we find especially in rational functions. And the way we find them is they're values of x that will make my denominator 0 and do not cancel out if I simplify the function. So for example, in the function I have here, x plus 2 over x plus 2 times x minus 3, x is not allowed to be negative 2, and x is not allowed to be 3. But we see that the x plus 2 cancels out. Because of that, the discontinuity that came from the x plus 2 is actually going to be a whole. So if you remember, wholes are discontinuities that get canceled out. But the x not being 3 came from x minus 3 that didn't cancel. That's going to be a vertical asymptote. The reason that we talk about this being a limit that involves infinity is that we're looking at what happens to a function as we approach a vertical asymptote. Wholes we'll deal with in section 3, but the vertical asymptote is as we approach a vertical asymptote, coming from the left or the right, our limit, in other words, the function value, is going to go up to positive infinity or down to negative infinity. And those are the only two choices as we approach a vertical asymptote. And that's why we say this is, when we're dealing with vertical asymptotes, the y values are either going to positive or negative infinity. So kind of some examples here. If we think of the function 1 over x, this is easiest to do with a little sketch. And if you don't really know what these look like, you're welcome to graph them on your calculator. But 1 over x looks like this. X is not allowed to be 0, and because we can't cancel that out, that is a vertical asymptote. So I do have a vertical asymptote right here. And I can see from the graph that as my function is approaching 0 from the left, it's going down to negative infinity. But as we approach our vertical asymptote from the right, my function is shooting up to positive infinity. Now, technically, infinity is not a number, just like negative infinity is not a number. So we could also say that these one-sided limits do not exist, because infinity isn't an actual value. But we typically do like to write infinity or negative infinity and say it does not exist for when they don't when the two limits don't match. Because this helps us, if all we're given is the limit, it helps us visualize what's happening to the graph. Now here, the two-sided limit definitely does not exist because the left and right-hand limits are not the same. And so there's kind of a very quick 1 over x look at the vertical asymptote for 1 over x. If we look at 1 over x squared, again, x is not going to be allowed to be 0. It doesn't cancel out, so I do have a vertical asymptote there. And my graph is going to look a little bit different. It's going to look like this. So coming from the left towards the vertical asymptote, our function is going off to infinity. Coming from the right, it's also going to infinity. Now, I could put two different things here. Because the left and right-hand limits are both infinity, I could say the two-sided limit is infinity. Or, kind of like I just explained briefly, because infinity is not a number, we can still say this does not exist.